Hello students, welcome to Shri Vardhaman Vidyalay online education. So today we will see part 3 of chapter 9, force and law of motion. So in this chapter we will discuss the Newton's third law of motions with example. So Newton's third law of motion. If a boy wearing roller skate standing facing on a wall and pushes the wall with his hand, the boy finds himself moving backward away from the wall. It appeared as if the wall also pushed the boy away. Actually, when the boy exerts a force on the wall by pushing it with a hand, then the wall exerts an equal force on the boy in the opposite direction. Since the boy is wearing a roller skater, so the opposite force exerted by the wall makes him move back. You can see here, so a boy existing in a force on the wall. So the wall exists an equal force on the boy in the opposite direction. So what happens? The boy will be moves in a backward equal distance in a backward direction. So the boy on the roller skate is exerting a force on the wall towards the left hand side. So the wall exerts an equal force on the boy towards right side. Due to this, the boy moves backward to the right side. So from these discussions, we conclude that when a boy exerts a force on the wall also exerts an equal and opposite force on the boy. So this is just an illustration of Newton's third law of motion. So when one body influences another body by applying the force, we say that the first body is interacting with the second body. In any way, the interactions between two bodies, there are always two forces that comes into play. And the Newton's third law of motions describe the relationship between these forces that come into play when the two bodies interact with each other. So you can see the example. So here you can see that is a boy is pushing the wall in these directions. So you can say that, so what happens, the wall also exerts a force on the boy in the opposite direction. So this you can see the direction. So the opposite force exerted by the wall makes the boy on the roller skate to move backward. Okay. Now, according to the Newton's third law of motions, whenever one body exerts a force on the another body, the second body exerts an equal and opposite force on the first body. So the force exerted by the first body on the second body is known as an action. So what is action? The force exerted by the first body on the second body. So this is the actions. This is the first. The first will be exerted on a wall. So this is an action. Next, the force exerted by the second body on the first body. So now this is a reaction. So that is a wall will exert a force on the body of a boy. So what happens? The boy will be moves in the backward directions. So the force exerted by the second body on the first body is called as a reaction. So once again I am repeating, the force exerted by the first body on the second body. So the first body exerts a force on the wall. That is a first is a boy. So this is the action, and second is a wall. So wall gives an equal force to the boy, but it in always in an opposite direction. So the boy is pushing the wall in this directions, but the boy will be moved in this directions. Okay. So the force exerted by the second body on the first body is known as reactions. It should be noted that actions and reactions are just two forces. Now definitions of Newton's third law of motions: to every actions there is an equal and opposite reactions. So what is the Newton's third law of motion? To every actions there is an equal and opposite reaction. So action and reactions acts on the two different bodies, but they act simultaneously. We will now describe a simple experiment to prove the Newton's third law of motions, that is to prove the actions and reactions are always equal and opposite. From example 1, why the gun recoils. When a bullet is fired from the gun, the force sending the bullet forward is equal to the force sending the gun backward. Now you can see that in the figure, what happens when a bullet is fired from the gun? So we are firing a bullet. What happens? The bullet will be moves in the forward directions. But what happens to the gun? The gun will be moves in the backward directions. But due to a high mass of a gun, it moves always in little distance backward. Draw diagram. So you can see the diagram to show the actions and reactions when a bullet is fired from the gun, gives backward jerk or kick to the shoulder of a gunman. So the gun is said to have been recoiled. A swimmer pushed the water backward with his hand and the feet to move in the forward directions in the water. So this is equal and opposite reactions of the force which pushes the swimmer forward. What happens? You can see that if a person is swimming in the water, he will push the water in the backward directions. So when a person is moving in a water in the backward directions, but what happens to the person? The persons will always move in the forward direction. So both are an actions and reactions are equal but in opposite direction. Second case of a boat and ship. During the rowing of a boat, the boatman pushed the water backward with the oar, but the water exerts an equal and opposite push on the boat which makes the boat move forward. In fact, harder the boatman push back the water with the oar, greater is the reaction force exerted by the water and fast the boat moves forward. So in this boat you can see that one, a person is pushing in a water in the backward with an oar. So what happens? So the boat will be moves in the forward directions. If it gives a large force to move the water in the backward direction, so the same force, what happens? The boat will move in a forward directions. Next one is the flying of jet aeroplanes and rocket. Jet aeroplane utilize the principle of actions and reactions. In the modern jet aircraft, the hot gases obtained by the rapid burning of the fuel rush out of the jet, that is a nozzle at the rear end, that is back end of the aircraft, at the great speed. The equal and opposite reactions of the backward growing gas push the aircraft forward at a great speed. So you can see that is when an aircraft will be moves. This is the aircraft. So what happens? The gas will be pushing out from a nozzle. Same force. What happens? The rocket, yeah, any aircraft will be moves in a forward directions. So we can demonstrate the principle of working of a jet engine by using a balloon filled with a compressed air. If a balloon filled with a compressed air and its mouth it with a released with its mouth on the left side, the balloon moves very fast towards the right side. This means that the balloon flies off in a opposite directions to that of an escaping air. Here the compressed air present in the balloon rushes to the left hand side with a high speed, that the equal and opposite reactions of left going air pushes the balloon to the right side. Now you can see the diagram. So the jet aeroplanes and it is related to the balloon. So you can see that this is a balloon. We are filling an air in the balloon. So when we release that knob of a balloon, what happens? The air will be rushed with a great speed in this direction. What happens to the balloon? The balloon will be moving in an opposite direction. This you can try in your home using this one. So now this is another example. As a sailor jump in the forward directions, the boat moves backward. So if a sailor is moving in a forward directions, what happens? The boat will be moves in a backward direction. So these are the examples of Newton's third law of motion. Now we can see the activity. So request two children to stand on two separate carts that you can see in the figure. Give them a bag full of sand or other heavy object and ask them to play the game of catching with the bag. Thus each of them receive an instant reactions as a result of throwing the sand back. You can paint a white line on the cart wheel to observe the motion of the two carts when the children throw the bag toward each other. Now, place the two children on the one cart and one on the another cart. The second law of motions can be seen, as this arrangement would show the different accelerations for the same force. So the cart shows in this activity can be constructed by using a 22 mm or 18 mm thick plywood board of about 50 centimeter to 100 centimeter with a two pair of hard ball bearing wing. So the skateboards are not as sufficient because it is very difficult to maintain the straight line motion. Okay, so these are the examples of an Newton's third law. So there are so many examples that we can discuss for the Newton's third law of an motion. Okay, now students, so in your book, the page number 118, so there is enough 4 blue questions. So you have to write that blue questions in your notebook. Thank you. We will meet in the next part of this session.